All right, welcome back. We're going to look at number 34, graphing inequality. Same as the last problem on the last video. We're going to graph this, and then we just have to have the added feature of shading part of this graph, either inside the parabola or outside the parabola. So let's get started. The first thing we want to do is probably not a bad idea to get an XY chart going. And I remember we labeled that the vertex. And how do we find the x value of the vertex? We do negative b over 2a. All right, and that looks like negative 2 over 2 times negative 2, which is positive 1/2. So it's negative 2 over negative 4, which is positive 1/2. All right, I'm going to plug that into my calculator. And I'm just going to show you another quick shortcut with this. We want x to be 1/2. So if we put 0.5, which is 1/2, or you could just do the fraction 1/2, and this STO button down here, make the arrow, and we're going to make that equal x. Now I can just type in the equation just like I see it. So I'm going to do that. Negative 2x squared plus 2x minus 1. That gives me negative 0.5. So negative 1/2. So that's my vertex. All right, so we want to look and see what that looks like here. Start with your set of axes. And 1/2 and negative 1/2 is right there. So I want to pick 2 points on either side of the vertex, 2 good points. So I'm going to pick 0 and negative 1. Okay, so let's do that really quick. We'll do this one by hand this time. So if I go up back to here, so if I'm picking 0 for this, all right, this one's easy. That cancels out and that cancels out. So when you're at 0, the y value is negative 1. And then we'll pick 1. So it's negative 2 times 1 squared plus 2 times 1 minus 1. 1 squared is 1, and 1 times negative 2 is negative 2, plus 2 minus 1. Negative 2 plus 2 is out, so it looks like we get, oh, I must have made a mistake somewhere. Let's see, 1 squared is 1, negative 2. Oh, I wanted to pick negative 1. That's why. 1 and 0 are the same, the distance away from the vertex. That's why I got the same answer. I got to change these. So this becomes negative 1 squared is positive 1, which makes this negative 2 minus 2 minus 1, which is negative 5. There we go. All right, so what I did, this will be a good thing to show you. What I did is I picked 0, and I got negative 1, so that puts me there. And then I accidentally chose 1 instead of negative 1, which put me there, which was the same distance away from the vertex. So I should have gotten the same answer, which I did. All right, but when I pick the negative 1 value, I got negative 5. So 1, 2, 3, 4, 5. And again, how far am I away from this line? Remember, this is a line of symmetry. So I'm a half, and then 1 full away, half, and then 1 full away, right there. And graph your line. All right, now this is a less than problem. So if I go back, less than. So I want to find my vertex and where are values less than the vertex. So above the vertex would be greater than. Below the vertex is less than, which means, and that's inside my parabola, so I'm going to shade inside the parabola. Now on your exam in a multiple choice test, even just knowing how to shade, you can probably get rid of a couple examples. So look at those closely. Maybe it can save you some time. Let's move on. So 35, I think we can get rid of the graph paper. 35 says solve using square roots. I don't care what method you use when you're solving these, but this is a nice square root problem. So because there's no linear term, no middle term, I can just move the constant over and solve this very similar to a linear equation. Divide both sides by 3, and that's going to give me x squared equals 9. Square root both sides. Those cancel. Remember, when you take the square root of both sides of an equation, you have to have both roots. So x equals plus or minus 3. All right, because negative 3 squared is positive 9, and positive 3 squared is positive 9. So there are two answers to that. All right. Solve using the zero product property. This is kind of how we end the factor problems in Chapter 10. So we want to get to this point. So this is a multiplication problem where a number times another number equals 0. The only way for that to be true is if they both equal 0. Now, they don't both equal 0 at the same time, but at one point, each of them has to be 0. So then I just solve these two linear equations. There's the first answer. Oh, sorry, you guys can't see that. And the next one, we're going to add 10 to both sides. And that's going to give me x equals 2. So those are my two answers for that problem. All right, now let's move on to 37. Okay, solve by factoring. So this is similar to a Chapter 9 problem. We have to factor this side, and then we're going to go back to what we just did in example 36. So I'm looking for factors of 40 that add to give me 13. So I can't think of any off the top of my head, but I know 4 and 10 are factors. Okay, 4 times 10 is 40. All right, so I'm going to just kind of prime factor these and just pair them up a little differently until I find my answer I'm looking for. Okay, factors of 40 that add. So I need two numbers that add. So I could do 2 times 2 times 2 is 8, and 5 and 8 is 13. So I'm going to do 8 and 5 is 13. So x minus 8, x minus 5. Should have saw that one right away. But it was good to show you just kind of another way to pair these up. So all of these numbers multiplied together are 40. I just had to find a different combination than 2 and 2 and 5 and 2. So I just multiplied the 3 2's together to get the 8, and 5 was left, and they do add to give you 13. And that equals 0. So now I'm going to set them both equal to 0 and solve. So x minus 8 equals 0, and x minus 5 equals 0. Okay, add 8 to both sides, I get x equals 8. Add 5 to get both sides, I get x equals 5. And those are the two places where the parabola crosses the x-axis. All right, 38. Solve by completing the square. All right, so I grabbed an extra sheet of paper for this one. So I'm going to start out by writing our equation like that. X squared minus 3x equals 4. Now, again, it's a multiple choice test, so if you just want to solve this, if you can see that this is factorable, which it is, you could just factor this. Or you could use the quadratic formula. It doesn't matter. But I will show you how to complete the square here. When you complete the square, you need to know what b over 2 squared is, and that's what you're going to add to both sides of the equation, all right, to make it a perfect square trinomial. And negative 3 over 2 squared is that value up there, which ends up being positive 9/4. I'm going to add to both sides. Okay? This equals 9/4. It'll always be adding because you're squaring the number, so any negative number will become positive. All right? Now we're going to make a perfect square trinomial, and if you remember from your notes, that guy is what this will factor into. So it ends up becoming x minus 3 over 2 squared equals, now I got to add 4 and 9/4, which isn't too bad. It's 16/4, that's what 4 is, plus 9/4, which is 25/4. Ooh, that's going to work out nice, 25/4. Okay. Now I just have to solve this. Opposite of squaring a number is taking the square root of. X minus 3 over 2 equals plus or minus. Don't forget, when you take the square root, you need both roots, and that's 5/2. I'm now going to add 3/2 to both sides of this equation. And remember, I'm going to go high road, low road. So I'm going to do x equals 3/2 plus 5/2. So that's the high road. And then we're going to take the low road. X equals 3/2 minus 5/2. This becomes 8/2, which is 4. 5 plus 3 is 8. Denominator stays the same. And this becomes negative 2 over 2, which is negative 1. 3 minus 5 is negative 2. Denominator stays the same. Divide, I get that. So those are my two answers. And like you said, it came out nice, or like I said, it came out nice, so we could have factored it, but whatever method you choose is fine with me. All right. Quadratic formula to solve. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so I'm going to plug all of those numbers in, a, b, and c, into this equation. So negative b, b is negative 8, so negative 8 is positive 8, plus or minus the square root of negative 8 squared minus 4 times 5 times negative 2, all over 2 times 5. Okay? Probably should have used another sheet of paper for this one too, but we'll be all right. Now the key to solving these problems is simply to take care of all this in as many steps as it's necessary for you to be accurate. Some can do it in a few steps. I'm going to try to do it in as few as possible. Let me check and see how much time I have. We got a couple minutes left, so I should be able to finish this. So I'm just going to fill it in down here. The 8 I'm not going to mess with yet. And I'm going to simplify the negative 8 squared, which is 64. Remember, I look at the signs. This is negative 4 times 5 times negative 2. It has two negatives, so that actually ends up being positive. 5 times 4 is 20. 20 times 2 is 40, all over 10. All right, I'm going to add these together. 8 plus or minus the square root of 104 over 10. That's a 10. There we go. I'm going to take the square root of 104, which is going to be a little more than 10. 10 point, we'll call it 10.2. So 8 plus or minus 10.2 over 10. All right, and now I'm going to take two equations, because this is two equations, all right, or two expressions. I'm going to go high road divided by 10 and low road divided by 10. So 8 plus 10.2 divided by 10, and that's going to be 18.2 divided by 10 is 1.82. Okay, duh. And then the next one, the low road, or I should say the low road, 8 minus 10.2 divided by 10 gives me negative 0.22. So those are my answers. Now you would not have been able to factor that problem to get that answer. So that is the quadratic formula. Same problem here. Use the quadratic formula to solve. It's the same exact thing, so I'm going to skip on, see if I can get some more of this done before this video runs out of time. Alright, so let's go to 41. The square root of 108. So what I'm looking for in these radical problems is a perfect square hidden in to 108. I'm going to try 4 right away. 4 is a perfect square, and 108 divided by 4 is 27. So 4 times 27 equals 108. All right. Now, right away, I see another perfect square in there, and that's 9. So if I do 9 times 4, that's 36. And if I divide 108 by 36, I get 3. So the square root of 108 equals 36 times 3. All right. So just a little math in my head here to figure out what perfect square was hidden in 108. It was 36. Now I'm going to take the square root of this perfect square, all right, which is 6, and this guy isn't a perfect square, so he doesn't get to come out and play, and that is what we have there. All right, 6 square roots of 3. All right, 42. 30 is 6 times 5. There's no perfect square in there, but 121 is a perfect square. It's 11. So the square root of 30 over 11 is what we're left with. Again, 30 is 3 times 2 times 5. No number pairs in there. There's not a perfect square hidden in 30. So not a perfect square. Can't simplify it any more than that. That is my answer. All right. 43. 8w cubed divided by 9. I think this is going to be my last one. Check that. That last problem was my last one. I'll make one more video, so I'll see you guys next time.